This is from Worksheet 3 from Learning Outcome 1 for Engineering Math 3. This is question 2E, looking at implicit differentiation. In this question, we're being asked to differentiate a function that contains both x and y functions, and one function containing both, in order to find the derivative dy by dx. And we'll just start and work through this systematically, and treat each term as we would normally, and remember the rules we have to apply for implicit differentiation. And sometimes it's best to write out our formula like this, put dy by dx before each of the terms we're going to deal with, and then just tackle them one by one. So that's exactly what I'm going to do, d by dx of cos squared y is equal to d by dx cos 2x plus 2y. So let's consider our first term. It's only in terms of x, so we're just going to do differentiation as we would do normally. So when we encounter a squared term in differentiation, the first thing we would normally do is multiply by the power 2, and we would reduce the power, so we would have our original function as well of cos x. But because it's not an x term we're dealing with, we would also multiply by the derivative of the thing that was squared. In this case, the thing being squared is cos x, and the derivative of cos x is, of course, minus sin x. So when we take the derivative of cos squared x, we get a 2 from our power, we get cos x, because the power has been reduced by 1, but we also multiply by the derivative of the power. And that's going to set us up nicely for our next derivative, because this is just going to be exactly the same if we were differentiating with respect to y. It'd be 2 cos y multiplied by minus sin y. But because this is a term entirely in y, we're also including a dy by dx here, because we haven't differentiated with respect to x, we have differentiated with respect to y, and we have to include this dy by dx term to account for that. Going across to the other side, we're dealing with a function in terms of x and y, but that shouldn't change our approach. We start methodically and we say, if we ever have to differentiate cos, we're going to have minus sin of the thing we were differentiating, which is 2x plus 2y. And then we would differentiate the content of that bracket, so and multiply by it. So here we're going to multiply by the derivative of 2x plus 2y, and of course derivative of 2x is x, and the derivative of 2y is 2, I should say. Derivative of 2y is 2, and derivative of 2y is also 2, but with respect to y. So we'll have 2, and again we'll have our dy by dx term here as well, because we've had to take the derivative with respect to y. So we're putting this dy by dx in here to, again, account for that. So we now have taken derivatives of all of our terms, and we have some terms with dy by dx multiplied by them, and some without. So what we're going to do is start multiplying out and tidying things up, and we want to end up with all of our dy by x terms on one side. We'll make that the left-hand side, and all of our non-dy by dx terms on the right. But I'll do a line of working first, just to do a bit of general tidying before we get into that. So write minus, and not for any particular reason, but I always write my sin x as before my cos x, is the minus 2 sin x cos x, minus 2 sin y cos y, dy by dx, is equal to, and we'll be multiplying everything out here, we'll be having minus 2 sin 2x plus 2y, and then we've got to add the multiple of 2 dy by dx times this as well, It's again, it's a minus. We have minus 2 sine 2x plus 2y, but this time dy by dx. So this allows us to tidy up all of our terms. So we'll add and subtract across to give us dy by dx on one side and other terms on the other. So I'm going to take the 2 sine 2x plus 2y dy by dx and add it across. So I'll have 2 sine 2x plus 2y dy by dx over here. And I'll add the 2 sine x cos x term to the other side because I don't want that over here. We'll keep our 2 sine y cos y term because it's got a dy by dx term in it on this side. And we'll keep our minus 2 sine 2x plus 2y term over here because there's no dy by dx. Now, having done probably the hard part of this problem, we now do the bit we always do at this point. We group dy by dx over here as a common factor and write out everything that's been multiplied by y. So here's our terms without that dy by dx. And the right-hand side we're doing nothing to just now because we're quite happy we've gathered all of our non-dy by dx terms over here. And then we divide through by the brackets on the left-hand side to leave dy by dx by itself. So if dy by dx is equal to 2 sine x cos x minus 2 sine 2x plus 2y, all divided by 2 sine 2x plus 2y minus 2 sine y cos y. Now, there's not too much we can do in terms of further simplification here, because although we've got a 2 sine 2x plus 2y at top, there's nothing else to do. But what we can notice is that all of these terms are multiplied by 2, so we can cancel by 2 top and bottom to get a final answer. Sine x cos x minus sine 2x plus 2y divided by sine 2x plus 2y minus 2 sine y cos y. And that concludes the question.